Let's press on with these radicals. So we know from the last video that we can only combine, we can only add and subtract if we're combining like terms. So let's look at this top one. This first one right here, I see a couple terms that are alike, and I see a term that is different. So we can combine our like terms, but that one that's different we're going to have to keep separate, okay? Let me write this another way. 2x minus 3y plus 5x. So the root 6's are the same, so that's why I called them both x's. The root 2 is different. That's just a y I called it. So if we had this, you would know how to do this. 2x plus 5x is 7x, and then we'd have minus 3y. We're going to follow that same pattern down here. 2 root 6 plus 5 root 6, that's just going to be 7 root 6 minus 3 root 2. And we can't take it any further because the root 6 and the root 2 are not alike, so we're just going to have to stay right there. Let's look at this next one. Now, the first look at this would tell us that all those terms are different, and you wouldn't be too far away from saying that. You wouldn't be too far off, but I see something. We can simplify these. Think about what the third roots are. Something times something times something. Maybe I need to add some over here in this. Let's say this. The third root of 8 is actually going to be 2. Because 2 times 2 times 2 is 8. The third root of 27 is going to be 3. And the third root of 64 is going to be, third root of 64 is going to be 4. So let's keep those things in mind as we do this. So root 16, or third root of 16, I see what I can do there. I can call this the third root of 8 times the third root of 2, because 8 times 2 is 16. And I know what the third root of 8 is. Third root of 8 is just 2. So we can just rewrite this as 5 times the third root of 2 plus 2 times the third root of 2. And then let's look at this one, 54. Well, I see third root of 27. Man, I am having trouble saying third root and writing other numbers. Third root of 27 times the third root of 2. And I know that the third root of 27 is just 3. And now, remember I had to bring that 3 down there, right there. That's where that 3 came from. 3 times 3, I know that that is 9. So this is just going to be minus 9 times the third root of 2. So 5 third root 2 plus 2 third root 2 minus 9 third root 2, 5 plus 2 minus 9. It's going to be negative 2 times the third root of 2. Okay, that's not bad. We can handle this. Fourth roots. I bet you would like me to write the fourth roots down here, and I probably should. The fourth root of 16 is going to be 2. The fourth root of 81 is going to be 3, and hopefully we're not going to have to go up any higher than that. So let's look at these problems. Fourth root of 81, well, I see down there it's just 3. Fourth root of 81 is just 3, so I've just got 3 times 3, which is 9. And the fourth root of 16 is just 2, so I've just got 9 minus 2, which is equal to 7. Well, that really did not turn out to be all that hard. Look at the next one. This looks difficult, but here's what I see. All those roots are the same. They're all the same. So all we have to do is combine our like terms. And I've got a 2 and a positive 12 and a negative 2. That's going to all work out to just be 12 of those things. 12 times the fifth root of 6. Hey, you know what? This isn't bad. We can do this. next question, what happens as we start to multiply these things? Well, let's distribute this. So we know we're going to have to multiply the numbers and then multiply the radicals. So 3 times 2 is going to be 6. And root 5 times root 5, that's just going to be 5. Plain old 5. And then, so we could, let's go ahead and simplify that right now. 6 times 5 is just going to be 30. So when we multiply that first right there, those first terms, that's just going to be 30. Now, let's multiply this. Well, there's no number for me to multiply the 3 by, no coefficient, so I'm just going to put the 3 down there. And then root 5 times root 3, that's just going to be root 15. And a quick check down here in my box, there's no numbers down here that I can divide, none of those perfect squares that I can divide by 15 by, so this is going to be our answer. Let's look at this next one. This next one is just a foiling, a double distributive. So let's do this. So root 7 times root 7, that's just going to be plain old 7. Root 7 times 2 root 3 is going to be a 2 root what? Root 7 times root 3, 2 root 21. Okay, now we're going to have to move to this. Negative 2 root 3 times root 7, well, that's just going to be a negative 2 root 3 root 7. That's root 21. And then negative 2 times positive 2 is going to be a negative 4. And root 3 times root 3, that's just going to be a plain old 3. So 4 times 3 is 12. 4 times 3 is just 12. Okay, so let's see what we have here. Let's combine our like terms. We've got a 7 and a negative 12, so that's going to be a negative 5. And then we have a 2 root 21 minus 2 root 21. Well, 2 minus 2 is 0. It just cancels out, and all we have left is negative 5. Great. Let's keep going. Oh, what am I going to do with this? Well, it would be tempting, wrong, but it would be tempting to just say, well, if we just square both of those, square and square roots just cancel, and that's just 5, and that's just 6, so that's just 11. Tempting, but wrong. We can't do that. And if you're not sure and you want to check it, let's just check it with some normal numbers in your calculator. Is 5 plus 6 squared the same thing as 5 squared, which is 25, plus 6 squared, which is 36? That would be 61. That's not the same thing, because 5 plus 6 is 11, and 11 squared is actually going to be 121. So we can see that it's not okay to just square each one of those things individually. So what does this actually mean? Well, root 5 times root 6 squared just means root 5 times root plus root 6 times itself. So let's FOIL this. Root 5 times root 5, that's just going to be plain old 5. Root 5 times root 6, that's going to be root 30. And then root 6 times root 5, that's just going to be a plain old root 30. Root 6 times root 6, that's a plain old 6. Just 6, plain old 6. Okay, so let's look at this. Let's combine these numbers first. 5 plus 6 is going to be 11. It would be tempting to call this next one root 60, but it's not. It's not root 60. Think about it as a 1 root 30 plus a 1 root 30. 1 root 30 plus 1 root 30 is just going to be 2 root 30. It's always a good idea to check that square root back here. Can I divide that by any of these perfect squares? So, whoops. Can I divide it by any of these perfect squares? Any of the numbers there? 4, 36, 100, 9, 49, 121, 16, 64, 25, 81. Nah, I can't. So I can't divide by any of those. So this is just right where our answer is going to stay. That's it. I know you've got this. It's not easy, but I know you can do it. Good luck.